Alright, our next video, also on projectile motion. We're going to, over this one and the next one, we're going to try a few sample problems together. I just want to, here's an object, a projectile. It's being thrown into the air at some angle theta. And just so we understand some terms, usually when we say height, it's the maximum height that it reaches, right at the top of its parabolic arc. And if you hear the word range in any questions, it's asking for how far does it go in the x. So I've labeled range dx, and I've labeled height dy on this diagram. First question, we're hiking along, come to a cliff overlooking a river here that I've drawn in blue. Cliff is 291 meters high. This river is 68.5 meters wide. I throw a rock out horizontally. It's got a velocity of 12.8 meters per second to start. Does it clear the river or not? And then the second part, how fast is it going when it hits either the water or the ground? And don't say 0. That answer is ridiculous. I would never ask such a question. So we need to decide where to start. And if you remember last video, we either start in the x or in the y. So I need to decide where I know most. I know in the x, I know vx, and I know dx, but this is not really a dx. This is something I'm going to compare to at the end. So really the only thing I do know is vx, but in the y, I've got a dy here. Let me write that in here. dy equals. I've got ay, I've got the initial y velocity, and let's keep in mind that the x velocity will not change. There's nothing making this thing go faster or slower in the x direction. We're going to pretend there's no wind. However, in the y, there will be a change in velocity. Initially, it has no up and down velocity, only a side to side, but that's going to change over time because it has the acceleration due to gravity of minus 9.8 meters per second squared. So in this question, I think we are going to start in the y. And I've written some stuff down that I know in the y. I know ay, viy, dy. I'm actually going to slide something in right here. I'm going to slide in a little negative sign. Because if this is his starting point, we have to differentiate things down from things up. And everything down is going to be negative and everything up is going to be positive. So I'm going to start trying to find time, and I'm going to use I'm going to use the formula d equals vit plus 1/2 a t squared. And since viy is 0, this term is gone. And I get minus 291 equals 1/2 minus 9.8 t squared. I multiply by 2, I divide by 9.8, and then I square root, and I get an answer for just time. And I have it written down here somewhere. Oh, 7.7. Like I said in the last video, time's the only thing I can bring back and forth. So now I'm going to go to the x. And when you're doing these questions, you should properly label your work like I am now. Don't make me guess where you're working. Tell me you're working in the Y. Tell me you're working in the X. I know that here, I know T. I'll write a little quick given here is 7.7. That's so annoying when it jumps like that. 7.7 seconds. I know V is 12.8. And I'm going to solve for D. It's VT. I plug in those numbers, and I get 98.6 meters. And so, to answer the first question, does it make it across the water? Yes. It clears the water. Now I have to figure out how fast it's going just before it hits the ground. If you ask yourself, well, where is it? What direction is it going just before it hits the ground? It's coming down kind of like this. Yes. And so it has a Y part, which I'll draw right here, and it has an X part, which I'll draw right here. Now the nice thing about this is the X part is still 12.8 meters per second. The Y part I'm not so sure about. This I'll call this VFY. Yes. How am I going to get this VFY? VFY. That's what I need. I guess I could use VFY squared equals VIY squared plus 2AD. A is minus 9.8, D is minus 291. This guy's 0. I'm going to get VFY. I'm going to get it minus 70. Let's call it minus 76. It's got quite a fast up and down velocity right near the end. So I'll put here 76 meters per second. Now I'm interested in this side over here. This is a right angled triangle, and I want this angle right here. No, that's incorrect. Let's just switch right there. I want this angle right here as a better angle to report from, because I can measure the angle up from the ground. So first I need to use Pythagorean theorem. If I use Pythagorean theorem to get this side, I get it to be about this guy equals about 77 meters per second. And I'm not going to show all that work. You can check it yourself using Pythagorean theorem, 76 and 12.8. I'm going to get about 77. Then I'm going to get this angle here using one of the trig functions. I'm going to get the angle to be about 80 degrees. So I would report my final velocity as VF, I'll give it a little vector, at 77 meters per second. And then I'm going to put 80 degrees above horizontal or ground. So I'll use the there's a pretty straightforward question where something is thrown out, started with only an x velocity, not a y. We stuck either in the y or the x. We have to be consistent. Don't start mixing variables for the two different directions. And then we figured out that, yeah, it cleared the water. And then we were also asked to figure out its final velocity as it was coming down. And it's coming pretty fast down at a pretty big angle.